What's up, 7th grade? Mr. Agnos here. In this video, we're going to practice dividing some positive and negative numbers. And the good news is that all the rules that we learned about multiplying positive and negatives still apply. So in other words, if the signs are the same, then our answer is going to be positive. If the signs are different, our answer will be negative. If we have a bunch of things that we have to divide, then you can just count the number of negative signs, right? If the number is even, well, they're all going to pair up, right? They all have a dance partner, and the entire thing becomes positive. But if the number of negative signs is odd, then you always have that one negative sign that doesn't have a dance partner, and that one negative sign turns the whole thing negative. So those two sets of rules there, they still apply. So let's take a look at some problems. Here they give me a bunch of division problems, and they just want me to find the values and put them here on the number line. I'm going to just go left to right. You're not going to see this little division symbol right here, right, that we see in a bunch of these problems. You're not going to see this too much more. Really, in 8th grade, we don't use it at all. What you are going to see is division problems written as fractions. So I'm going to rewrite these as fractions. So negative 22 divided by 11. The way you're more likely going to see that in the future is negative 22 divided by 11. All right. Well, negative divided by a positive, right? The signs are different. So I know my answer is negative, and 22 divided by 11 is 2. So I can grab this little dot here and put it at negative 2. 0 divided by negative 3. So I have 0 on top, and I'm dividing it by negative 3. All right, 0 divided by anything is 0. And 0 doesn't have a sign. It's neither positive nor negative. So this one goes right here at 0. Um, 48 divided by negative 12. So this one's already written as a fraction. 48 divided by negative 12. The signs are different, right? Positive divided by negative. So my answer is negative. 48 divided by 12 is 4. So I'll grab this one and put it at negative 4. Negative 20 divided by negative 4. All right, negative 20 divided by negative 4. All right, this is the first one where we see, hey, we have two negatives, and they're going to become dance partners, right? And that's a positive thing. So these two negatives, the signs are the same, so my answer is going to be positive. Now, we don't usually put a plus in front. You just write the number, right? And then 20 divided by 4 is 5. So really, you're not going to see this plus sign here. We're just going to have a 5. So I'll take this and put it at 5. All right, next up, 18 divided, excuse me, 18 divided by 0. All right, this is the big no-no, right? You can't divide something by 0. It doesn't make any sense. Remember, multiplication is the opposite of division, right? So if we could divide something by 0, it implies that there's some number, right? So I have some other number over here that I can multiply by 0 and get 18, right? So I'll show you an example. 12 divided by 3 is equal to 4. Well, if I want to reverse this, I would say, well, 3 times 4, right? I take this number, I multiply it by this one, and it gives me this number. But think about, how would that ever work here? 0, I would have to multiply it by some number. I'll just use n. So 0 times n is equal to 18. 0 times anything is 0. So this can never work. So we say that this is undefined. It doesn't have a value. So we just say it's undefined right here. And so they want us to just leave it in the little tray up here. All right, negative 10 divided by 0. Same thing. Negative 10 divided by 0. You can't do it. It doesn't make sense. So we will leave it in the tray. 8 divided by 4. 8 divided by 4 is equal to 2, right? Because 4 times 2 will give me 8. And they're both positive, so that's going to be positive. Negative 10 divided by 2. Negative 10 divided by 2. I have a negative divided by a positive, so it's negative, and 10 divided by 2 is 5. And last one. Excuse me. Negative 27 divided by negative 9. The signs are the same. They're going to pair up and make a positive. 27 divided by 9 is 3. There we go. Okay, moving on. It's still giving me this weird error message every now and then. All right, what this screen is trying to tell us is that you can use different combinations of division problems to get the same number. So I'm not going to do all of these. I'm just going to, what it's saying here is, okay, let's take this number negative 3. So I'm going to take negative 3, and let's write some division problems that are going to equal negative 3 using these numbers up here. And it turns out there's actually a lot of ways I can do that. I could take, for example, negative 6 and divide it by positive 2. That's going to equal negative 3, right? I have a negative divided by a positive, which gives me the negative, and 6 divided by 2, which gives me the 3. But that's not the only possibility. What if I switch the negative to the bottom? I could do positive 6 divided by a negative 2. That's also going to equal negative 3. I still only have one negative sign, which makes the whole thing negative, and then 6 divided by 2 is 3. What about, I could use negative 3 and 1. So negative 3 divided by 1, that's equal to negative 3. And there's actually one more option, which would be to switch the negative sign to the bottom here. So what they're trying to show you with this slide is that there are a whole bunch of different ways to create a negative 3 using division. In fact, there's an infinite number of ways, right? I could do negative 9 divided by 3, negative 12 divided by 4, negative 15 divided by 5, and I could just keep doing that all the way to infinity, right? Which goes on forever and ever. Let's look at 0. How could I get 0? Well, to get 0, I need a 0 in the numerator. So I could divide 0 by anything. I could divide it by negative 4. I could divide it by 3. I could divide it by a billion. I know a billion's not on my list, but just trying to prove a point here. Let's see, a billion has 9 zeros after it. So it doesn't matter what I divide 0 by, it's always going to equal 0. All right, so you do have some questions where they ask you to sort of, hey, which fractions are going to equal, they give you a number, right? They give you this number here, and then they'll ask you to select fractions that equal that number. All right, and our last problem that I'm going to go over. All right, glaciers, right? It says a glacier retreated 21 feet over 6 years. Express this as a unit rate. In other words, how much did it retreat in 1 year? So when it says retreat, here's the glacier right now. Okay, and then we got this climate change going on. So the glacier is melting. So 6 years later, we come back and we measure, and the glacier now only goes to here, right? So it retreated 21 feet. And because because we're taking away, we're gonna use a negative 21, right, to represent hey, we lost 21 feet. And this happened over the course of 6 years. So if I want to find the unit rate here, I just say, okay, we lost 21 feet in 6 years, let's just divide by 6, and that'll tell us how many in 1 year. So I'm just going to do negative 21 divided by 6. For this type of question, I think they're going to want you to do a mixed number as your answer. So I know my answer is going to be negative. So let's just do 21 divided by 6, and then we'll make the answer negative. So 21 divided by 6. 6 goes into 21 3 times. 3 times 6 is 18. All right, so 3 and 3 6. That's my answer, right? This is the whole number. So there's the whole. This is the numerator of the fraction. And then I always use the same denominator. So this is how much we lose in 1 year. Now, if I were to type this into the computer on the homework, it's going to mark it wrong because 3 6 is not simplified. This is equal to negative 3. My whole number stays the same. Well, 3 6 is 1/2. So this glacier is retreating 3.5 feet per year. Okay, guys, so hopefully you see that the jump from multiplication to division is not that big a deal. All the same rules still apply. Look forward to seeing you guys in class, and make sure to ask lots of questions. See you soon.